Guys, so we are starting with the next part of the chapter of AC, that is alternating current. Okay, so we stopped with the homework question which I gave you regarding the find the average current, right, for a half cycle, right, half cycle of a sinusoidal wave, and I gave you the time period for it as 2 pi by omega. Only one person out of you guys at least tried it and asked me how to do it, but since none of you guys, other than that is I'm not explicitly telling the name, other than her, no one gave or tried even to do that problem. So if possible, I will try to do it in this video itself. If not, I will be sending it as a paper or as a PDF file, and in the classroom I will upload it. Okay, so let's move on with the chapters or the portion which I'm going to do today. So if you had done it correctly, you will find that for average of half cycle, right, for that question is I I naught by 2 is something which the person who tried it, right, has got, but the actual answer is 2 I naught by pi, right. That is the average current for half cycle. Similarly, that will EMF or the voltage for half cycle is 2 epsilon naught by pi. These two are very important for the next section also. That's why I told the answers. Okay, so 2 epsilon naught by pi and 2 I naught by pi. Okay, now what we are going to do is, after calculating this value, we are moving with the next section, which is if suppose someone asks you to find the average of the square of this sine wave, right, average of the square of the sine wave. That is, you are asked what is the average of I naught square sine square omega t, right. That is average of I. This I is equal to I naught sine omega t, so I squared will be I naught square sine omega t. So I hope you remember what is the average of any function f of t. It is integral 0 to t f of t dt whole divided by integral 0 to t dt, right. That was the function common equation, right. Depending on this, I can do this also, right. So that will be integral 0 to, here time period is 2 pi by omega, right. That is for one cycle, right. And f of t will be this function, that is I naught square sine square omega t dt whole divided by integral 0 to 2 pi by omega dt. Clear? Right. Now what we are going to do is we are going to integrate this function. So it will be, sorry, take the black color itself, right, equal to 0 to 2 pi by omega, right. I naught square is constant function. I bring it outside. It will be sine squared omega t dt whole divided by, see, this function, that is integral dt is t itself, right. And there is an upper limit 2 pi by omega, lower limit 0, right. Now that means here I'm not integrating the started with the numerator, guys. I'm just doing the denominator. In the denominator section, where in t I'm substituting the upper limit, right. Upper limit minus lower limit becomes what? 2 pi by omega, right. That is upper limit minus 0, right. So that means the answer is just 2 pi by omega, right. So in the denominator I'm now going to write just 2 pi by omega. So this is 2 pi by omega. So I can bring this numerator in the the denominator in the numerator section, so it becomes omega I naught squared by 2 pi, right. Integral 0 to 2 pi by omega, right. Then start with sine squared t, right. If some of you guys might be remembering in the case of trigonometry, but some of you guys will not be remembering, and some of you guys are purely biology, so you might not be knowing this. So there is a function with sine, which is sine squared x is equal to 1 minus cos 2x by 2. There is a function like this, or relationship between sine squared x and cos. That is sine squared x is equal to 1 minus cos 2x by 2. In this problem, in place of x it is omega t. So here I can write 1 minus cos 2 omega t whole divided by 2. Right, and there is a dt also. Clear? Right, now moving on. So this is equal to, right, we stopped with this function, remember this section, right? So I'm continuing with that also. So omega I naught squared by 2 pi, right, bracket, there is a 1 by 2, right, 1 by 2 for 1 and 1 by 2 for cos 2 omega t. So 1 by 2, 1 integral dt is t itself, right? So or I can write here, I will write the entire step, guys. Integral 2 pi by omega dt, 1 dt, right, minus 1 by 2 integral 0 to 2 pi by omega cos 2 omega t dt, right, bracket close, right, bracket close. If I want like this, I will change, bracket closed, right? As much is clear. Now that is equal to I naught squared omega by 2 pi. I just rearrange it, bracket, right? Now guys, this function, right, so before moving to that part, let's take, I'm going to take a small part, remember. See, we drew or we took this one, right, this is a sine function and this is a cosine function, right? So for one cycle from this to this end, right, for one cycle I just told you the average, or I can say actually sum of, right, sine x, right, integral sine x for 0 to t for one time period dx is equal to 0. That something which you have to remember. Similarly for cos also, for a time interval for one cycle, integral cos x or cos ax, I can say cos ax, here I can write sine ax dx is equal to 0. Why? Average, right? You're finding the area. This is plus, this is minus, so both of them will be cancelling out. So integral 0 to, not for t by 2 guys, not for half cycle, for full cycle, which we have calculated till now. For full cycle, for sine function or cos function, the value is 0, right? It's very important criteria, remember it. Okay, now moving on with the problem, guys. So we stopped till here, right? Now this means this entire function, which this one is equal to 0. Clear? Because it's a cos 2 omega t. For 0 to 2 pi omega means that is for one cycle. So one cycle cos function is equal to 0. So there is only this function, this much part, that is 1 by 2 what, integral 0 to 2 pi omega dt. So integral dt or is t, so 1 by t, t, upper limit is 2 pi by omega, lower limit is 0. So upper limit minus lower limit, so there will be only 2 pi by omega. So it is I naught squared omega by 2 pi, 1 by 2, 2 pi by omega, right? I can cancel 2 pi, can cancel omega. So there will be only one answer, I naught squared by 2. So average of square of the current is equal, of an AC current is I squared by I naught squared by 2, right? Similarly, if you find for half cycle, that is I squares half cycles average, that is also you'll find it as I naught squared by 2. Try it by yourself. This I will never do it, guys. I will just tell you a clue, that is initially it was 0 to 2 pi by omega, right? Now you have to replace it with pi by omega. In place of 2 pi by omega, integration should be done from 0 to pi by omega for half cycle. Okay, so why did we do this much of tedious job is, now we are going to understand that what is the value of I square. We just wrote it, remember we wrote it like this, integral I naught square 0 to 2 pi by omega, and there was sine square omega t dt, remember, divided by integral 0 to 2 pi by 2 pi dt. This we have written in the earlier section, remember. I hope you remember. If not, we can go back, right? This one they have written. So similarly, so I'm writing it again. So we just found the value of this one as I naught square, remember, I naught square by 2. We just found that value, right? I'm going to compare these two equations, right? So when I compare this part, I naught square, there is an I naught square, right? So if I compare these two equations, I can confirm that 1 by 2 is equal to integral 0 to 2 pi by omega sine square omega t dt integral 0 to 2 pi by omega dt. See this value, please by heart it. Integral 0 to 2 pi by omega sine square omega t dt divided by integral 0 to 2 pi dt's value is 1 by 2. It will be very useful later on. Okay, right? Now similarly, if current I can write in this form, then for EMF also, right, for average of EMF will be, for a full cycle will be E naught square by 2, just like I naught squared by 2. Similarly, for half cycle also, it will be E naught square by 2, right? Keep that in mind. Since current and EMF are both function of time, right? This current as well as EMF are both function of time, then power will be also function of time. Very important criteria. So as the current and voltage change with time, power also changes with time. But while I pay my electricity bill, right, we have to pay our monthly, I think, electricity bill for into KSCB, we cannot calculate each and individual power. Today how much power I have consumed, today how much my whole house appliances has consumed, I cannot calculate, right? And I cannot wait till night for that. So what we do is, for a fixed time interval is taken, an average power for that interval is still calculated. That's how the case will be, right? For 1 month, right, or for 30 days they calculate. Now usually it is 3 months now, right? So for that period of time, average power consumption is not, average is calculated, right? So why did we do this tedious job of finding I naught square or I square, right? Average of I square, right? This is where we are going to link the scientific world with the common world, right? In my home, right, in my home, the normal AC is of 50 hertz. I asked you to do this as homework, right? And nobody submitted it. Well done, good. So normal frequency range in our supply or in our home applications is 50 hertz, right? KSAB provides for daily, every home receives an AC of 50 hertz. Similarly, a voltage of 220 volt, not the 3-phase, okay, right? So 220 volt and 50 hertz. Now what do you mean by 50 hertz? That is a frequency. That means in 1 second, right, 50 cycles of sine waves will be there. How many? 50 cycles, like this. This is 1 cycle, right? Like that there will be 50 cycles, right? So in 1 cycle, how many zeros are there? This is 1 0, this is another 0. Don't take this one as the next 0, okay? This is a, this 0 is a part of the next wave, right? So for one wave there are 2 zeros, right? That means, or I can say for 1 cycle there are 2 zeros, right? So for 50 cycles, how many zeros will be there? 100 zeros will be there, right? So guys, the current which you are receiving in your home, that means that current is turning off and on 100 times. 100 times it is on and 100 times it is off, but it is so high speed that it is not visible by your naked eye, right? And I just told you the normal supply voltage is how much? 220 volt. right? But the problem, I hope you understood this concept, right? Regarding the 50 hertz, etc. That is, in, say, if I just told you 50 cycles, right? That is a 50 hertz meaning. So 50 cycles are happening in 1 second. So in 1 second, right, how many times the zeros are coming? How many zeros are coming? 100 zeros, right? So in 1 second, 100 times the blinking is happening. That is not able to be seen by your naked eye. Okay, now let's move on. So normal voltage supply, how much I just told you, it is 220 volt, right? So if it is 220 volt, we just told that epsilon naught is equal to epsilon sine omega t. That is, the voltage is a function of time, right? That means the voltage or the EMF has to be changing according with time, right? So but I just told you voltage as a constant number, right? That is where our term called RMS, root mean squared voltage, that comes up. Very, very important term, RMS voltage, right? So the 220 volt which you see here is the RMS value of the AC voltage. What is RMS? Root mean square, root mean square, right? So the 220 volt which I just told you is the root mean square voltage, or usually it is written as VRMS, or you can write as ERMS, like this, right? So this is the voltage which you receive in your home. You actually don't receive the proper total current. The average current which you receive is root mean square current. Now I will tell you explicitly how it is understood. Okay, now this 220 is equal to, how can root, right? So root, I am writing mean of square of voltage, right? See, root mean square. Now suddenly I am just remembering, I just found E naught, or for full cycle E squared is E naught squared by 2, right? We just found, right? So I can substitute this value here also, right? E naught squared by 2, or I can write this one as E naught by root 2, right? So what is 220 volt? It is ERMS, right? That is RMS voltage is equal to E naught by root 2, where E naught, which you have written in the previous equation, I hope that is present here. No, I'll write again, right? Which you write it as E is equal to E naught sine omega t, right? That is how you write the voltage equation. Here this E naught is known as peak voltage. It is peak voltage. That is, for any AC current, the maximum voltage which can come up is known as peak voltage. And similarly, when you have an equation like this, that is I is equal to I naught sine omega t. I naught is the peak current. So you learn two terms, what and all? RMS voltage, similarly RMS current. Okay, I didn't tell about RMS current, right? We just talked what is RMS voltage. It is E naught by root 2, right? 1 by root 2 times peak EMF. Similarly, what is IRMS? I can write it as I naught peak current divided by root 2. Both the equations are important, right? Clear? Now moving on. Now I am going to deal with the same equation, guys. Now E naught, right? This E naught can be written as ERMS into root 2, right? Now I just told you the RMS amount or voltage which you receive is 220 volt. Is root 2, that is, it is around 311 volt. That means peak value of the voltage which you can receive in your home is 311 volt, right? So even if we say that the voltage which you are receiving is 220 volt, it is not the maximum value, it is the mean square value, or root to mean square, or RMS voltage. Actually the peak voltage which you can you can receive is 311 volt, right? So that's why, see, some of you, if anybody asks you whether a 220 volt AC is dangerous or 220 volt DC is dangerous, means 220 volt AC is dangerous, because 220 volt AC means minimum, right, root mean square voltage which can received by you is 220 volt, but that means actually peak voltage which can be received, maximum voltage can be till what, how much, 311 volt. 220 volt DC means you are any time you will receive this much voltage only, 100% sure. But AC, if you are getting 220 volt, means that means the maximum voltage can go up to 311 volt, which is higher, right? So that's why AC voltage is dangerous, much more. Clear? Now what is the significance of RMS value of or voltage or current? Okay, let's draw with the graph here. This is my sinusoidal waveform, right? This is, let's say it is 2 pi by t, right? So, or I can say 2 pi by omega, right? That is time period section, 2 pi by t, right? Or I can write this in the frequency form as 2 pi f. And I just told you what is the frequency of our supply. It is 50 hertz. So I can write omega is equal to 2 pi into 50, or I can write it as 100 pi, right? And we just wrote what is the actual equation for EM or voltage. Till now we have learned it as E naught sine omega t, right? In place of omega, I'm going to substitute this value, that is E is equal to, what is E naught? We just found the E naught value also. Remember previously E naught is 311 volt, right? So I'm going to substitute that value here also. So it is in place of E 300, right? So it is 311 volt sine omega is 100 by t. So this is the actual or the real representation. In the real life, if you are asked to represent an AC voltage, this is how you are supposed to substitute the values. That is, a voltage E is equal to 311 into sine 100 pi t. This is the representation of a voltage which you receive in India, okay? Clear? Actual real life. This is the significance or why we have done the calculation, etc. Right? Now suppose you're making you a layman or an ordinary person to understand this, how and how function is happening, right? That person doesn't know the sine wave, etc., right? So see, first you have to understand, right? So first let's make ourselves understood the concept, right? So suppose this is our resistance R, right, and the current I of t, which is depending upon the time period, is flowing. Now how would I write heat? How would I write heat? Heat is a form of energy, right? So I can either write it as energy or I can just write it as heat. It's just I square RT, right? That is how this representation should be there, right? I squared RT. Now suppose I am calculating heat for a very small time interval of time, so that is say dt. So the heat will be very small, that means I will write it as dH. Small heat is equal to I square R dt, that is for the small time interval, right? Now if you are asked for a total heat, if you are asked, you have to then integrate the entire function. So R is constant, I will write it outside, I squared dt, right? Clear? Simple. So I can write this one, I am giving I of t, right? So I'm going to replace it, guys. So I am supposed to write it as I squared t dt, because I of t is coming, right? Clear? Now I am supposed to find this value. Either you can directly integrate it, but there is a simpler way by using the answers which you have solved or found in the earlier section. What was this value? That is average of I squared was supposed to be written as I square of t dt, right, whole divided by dt, remember, right? I had not written the limit, guys. It's okay. So what is integral dt? It is t, right? So if I bring it here, it will be average of I squared into t is equal to I squared of t dt, right? Now can't I substitute this value here, right? This is I squared t dt, this is also I squared t dt, and what is the value of I squared t dt? It is average of I squared into t. So let's substitute here. So it will be h is equal to r, that is a constant, right? Clear? I squared, that is average, sorry, t. Right, now we have found the average of one cycle of current square. Remember, it is I naught squared by 2, that is r into I naught squared by 2t. Clear? Right, now what can I do? Now what I am going to do is, straight away I am writing it as r into I naught squared by 2t. Right, but actually we have learned that heat is always supposed to be written as current squared into r into t, r into t, r into t. But the current is supposed to be written in this form only, but here I am writing it as what? I naught squared by 2, right? So that means I have to write this as, in this form I am writing, right? IRMS squared. Let's just write like this. Right, now this heat equation is quite similar to this equation. See, h is equal to r into I squared t, or I squared rt, same, right? But now we have just replaced this value I naught squared by 2 with the value RMS, right? This is how we just remove the higher type of calculations. This is how you make a layman understand, right? So that means IRMS, now we get a value like this. IRMS is equal to I naught, right, by root 2, right? That is, there is, if you are supposed to, in the AC form, you are comparing AC and DC, right? I hope you understand. In DC, etc., the heat is always written by the formula H is equal to I squared RT. Right, but when I calculate the heat for an AC supply, it came about like R into I naught squared by 2 into T, right? So just to compare an AC and DC, I'm writing the AC's heat equation again. I'm rearranging it and making it into a new form like this, right? How? I is equal to I squared, I am writing it as a new term which is IRMS squared into RT, so that AC's equation is now similar to the DC's equation, right? So that I can easily say that IRMS, right, that is IRMS current in DC is quite similar to the current in AC. See, listen to it properly, guys. So I can easily say that IRMS current, right, this one, IRMS current is quite similar to the what? Basic current of DC supply, right? That's why a new quantity called RMS current was introduced. This RMS current is never seen in the case of DC. It is only seen in AC. So what is RMS current? RMS current is a quantity which is arbitrarily introduced, right? So that RMS current is equivalent to DC current, right? In the ways of, or in the basis of value, okay, not in the case of character. And RMS current is root mean of the square of the current. Clear? That is, you are taking first, you will calculate the square of the current for different instances, then you will find its mean, right? I1 squared plus I2 squared, like that, and then you will find the average. That is your IRMS current, and it is equal to 1 by root 2 times peak value of current. Similarly, the case of voltage. Clear? ERMS is equal to E naught by root 2. Clear? Since we are not able to do the homework numerical in this video, we'll do that in the, or I will send it as a photo. Okay.